In this video, we're going to talk about correlational research methods. This is specifically for AP Psychology class or Psychology 101 if you're taking it in college. So the purpose of correlational research methods is to show whether a relationship or correlation between two variables exists. So an example would be, is intelligence correlated with max bench press? The correlation doesn't mean causation, so if there's correlation between those two things, it doesn't mean that there's causation. We will discuss that further. Okay, so let's talk about correlation coefficient. The correlation coefficient is a statistical measure that shows how closely two variables are related to one another, or how well one predicts the other. If you look at the scale, correlation coefficient can go from -1 to 1. At -1, there's a perfect negative correlation. In other words, as one variable goes up, the other one goes down. And then on the right side, there's a perfect positive correlation where as one variable goes up, the other variable also increases, and as one goes down, the other also goes down. At 0, we have no correlation at all. There's no relationship between the two variables. They don't really predict one another. And then at 0.5, so -0.5, you can see that there's still a negative correlation, but it's just a little weaker. And at 0.5, there's still a positive correlation, but it's still weaker than correlation of 1. Now, what we have here, which what we have right here, is called a scatter plot. And this line is called the line of best fit. It's just showing the trend and kind of a putting together of all the lines. So let's go through some examples. Positive correlation. If you study more, then your score will be higher. That's an example of positive correlation because both variables increase at the same time, or increase together. If there are less clouds, then the probability of rain is also lower, so the variables go down together. If a person exercises more, then they're going to have better heart health. So those two things increase together. For negative correlation, if you practice more, then you'll make less mistakes. So that's a negative correlation. Age doesn't really increase, but if someone's age is younger, then their agility is likely to be higher than if they were older. And then as ACE inhibitor increase, or well, actually that's incorrect. It should be increases right there. So my fault on that one. Now, we talked about correlation doesn't mean causation. Here's a scatter plot that shows the number of shark attacks and consumption of ice cream throughout time. And as you can see here, it looks like shark attacks are correlated with how much ice cream people eat. Now, does this mean that eating more ice cream causes shark attacks? It doesn't necessarily mean that. Can we provide an alternate explanation that says maybe people eat more ice cream in the summertime and they're also at the beach in the summertime, and if they're at the beach, then they're more likely to be attacked by a shark than if they're not. So what we've identified here is the time of the year is also a variable, and it's not one of our two variables. It's not our independent variable, it's not our dependent variable, but it does change the results. It does affect the relationship between the two variables we're looking at. So this is called a confounding variable. So that's the video. Thank Thank you for watching.